let's examine this transformation of functions right here with our absolute value for number 1. So the first thing we need to remember with our transformation of absolute values is that the parent function is f of x equals the absolute value of x. Another way of writing that, f of x is the same thing as y. Okay, so let's go ahead and graph the parent function. We're going to use our graphing calculator. I'm going to go up to y1 and I'm going to graph the absolute value. Math, number, absolute value, x. So let's just see what our parent function looks like when we graph it. Okay, so there it is. So we can see that our vertex is right here at the origin. So our vertex, I'm going to write this over here. The vertex is at 0, 0. And our axis of symmetry happens to be our y-axis. And the equation for y-axis is x equals 0. So that's our axis of symmetry. Okay, so that's for our parent function. So we're going to compare everything to our parent function. The other thing that's important with absolute value is we're going to look just on the right side of our function, and we're going to pretend that we can take the slope. It's a straight line, so we can. So to do the slope, I'm up 1 over 1, up 1 over 1, up 1 over 1. My slope of the right side, so I'm only looking at the right side. So the right side slope is 1. So those are all the important features that you need to look at. So let's look at this function here, and let's see how that's different. So we're going to play around with our calculator a little bit. So go to y equals, go down to y2, and let's put in this function and let's see what happens. I'm still leaving my parent function up here because I want to do a comparison. So I'm going to do 2, math, number, absolute value, x plus 4, close my absolute value, minus 3. So let's graph that and see what that looks like. Well, we can notice right away a couple of things. First of all, my vertex has changed. My vertex is different, isn't it? And this also looks a little thinner, like the ends have been pulled up a little bit. So something is happening in our function that has changed the vertex and that has made my absolute value a little skinnier. So we're going to look at this and try to figure out what did what. So let's go back to our y equals. Let's do this. Let's do a y3. Let's take that 2 out of there and just put in the absolute value of x plus 4 minus 3. So I took that 2 away from the front of the absolute value. So let's push graph and let's see what happens. Okay, so what do you notice? I'm going to turn off our parent function for a minute. So I'm going to go up to parent function, my equal sign, unselect that. So my parent function isn't there anymore. So this is what's graphing right now is what's in the book, and what is graphing right now is without the 2 in the front. So you can see my vertex is the same, but what was different between my red equation and my black equation? Well, my red equation, y2, had a 2 in the front, and my black equation, y3, did not have a 2 in the front. Everything else is exactly the same. So it looks like this 2 made my function get kind of squished a little bit. So the 2 was actually a stretch. vertically. So that would be a vertical stretch by 2. Let's look at our table. So if I go to second table, I'm going to look at my graph, and I'm going to look at my my x values and my y values. So we can see here, well, this is hard to see because it's been shifted. Let's play around with this a little bit more. Let's play with my absolute value, and we're going to create another function. So I'm going to go down, I'm going to turn off y2 because I don't want to retype it, and I do that just by getting on the equal sign. So in y4, I'm going to put 2 absolute value of x. So let's see what that does. 2 math number absolute value x. Okay? So what I'm going to look at is I'm going to look at my absolute value and 2 times the absolute value, and let's see what that does to my graph. So now I have y1 on and y4 on. So here's my parent function, and there's my vertical stretch, because remember we said that the 2 was stretching it, so it should do that with any function that I have. So now let's look at our table. So when I look at my table, let's look at y1 and y4. Notice that it goes 1, 2, 2, 4, 3, 6, 4, 8. So how did my y's change? Well, it looks like to get from y1 to y2, didn't my y value double? So with my parent function, if I multiply my y value by 2, I get my new y value. And in fact, that's what happens in my graph. So my y value has been doubled. So here, where x is 2, my parent function is 2. But where x is 2, my stretch function is now 4. Where x was 3, my parent function was 3. Where x was 3, my stretch function is now y at 6. So that's the effect that this 2 is having in the front of my absolute value. Okay, let's go back and let's look at some more equations here. Okay, so we see what this 2 did. So let's see what the 4 and the negative 3 are doing. So I'm going to go back over to our original, turn it on. I'm going to turn off this one down here at the bottom. So now I just have my parent function and the function I'm interested in. Let's go back and look at that graph. There's my parent function. Okay, so it looks like we've already talked about that, how this stretched. Okay, it's stretched by 2 vertically, but my vertex has shifted from 0, 0 to that point down there. So let's see, what is my vertex? How can I find my vertex by looking at this graph? Well, I could kind of look at the tick marks, but I'm going to show you another way, because you're going to need to know this technique when we talk about quadratics and the minimum and maximum. So we're going to find this vertex. We're going to let the calculator do it for us. So we're going to do second calc, and we're going to do what's called the minimum, because that V was at the very bottom. This V is at the very bottom. So that's the minimum point. Now, you see my cursor is on the wrong function. I don't want it on the absolute value of x. So I'm going to push my up arrow, and notice how it jumped to right here. That's the exact equation I want. It's the same one as this. So it's asking me some questions down here though. It says left bound. What does that mean? Well, left bound means I want to be left of the point that I'm interested in. And the point that I'm interested in is right here. Okay? That point is where I'm interested in. So I'm going to move my cursor left to what I want. My computer just shut off. Give me a minute. To the left of what I want. So now it's to the left of the vertex right there. I'm going to push enter, and my calculator puts this nice line down there with this little triangle arrow. That means it's going to look for everything this way. Then it asks me for right bound, so I want to go right of that point that I'm interested in. So I move my cursor to the right, and I'm going to push enter. So notice it gives me these arrows up on top, which means it's going to look for the lowest value in between this interval, within this interval right here. So now it asks me to guess. I don't guess. I push enter, and notice what it tells me. It says my minimum is negative 3.99999 for x and negative 2.99999 for y. Really, that's the same as x is negative 4 and y is negative 3. So let's write that down. This is my vertex. My vertex is at negative 4, negative 3. Okay, so let's look back up at my equation. Here I have a negative 4, here I have a positive 4. Here I have a negative 3, here I have a negative 3. Perhaps these numbers are telling me my vertex, and in fact they are. When I don't have a negative in front of this x, notice how that x is just plain x inside the absolute value, then my vertex for my x value for my vertex is going to be opposite, same. So I want to think about opposite, same. And what we call those points are h and k. So h and k gives us our vertex. So this function has shifted left 4, down 3. So I would say left 4, down 3 from the parent function. So we can see that this 2 in front of the absolute value gave us a vertical stretch. This 4 plus 4 shifted our function to the left 4, and this negative 3 shifted our function down 3. So it went left 4, down 3. Okay, so one more thing I want to show you. I'm going to go back to my y equals. I'm going to turn off my parent function for a minute, and I'm going to go down, and I'm going to make my y3 look just like my y2, except I'm going to do something a little different. So I can insert something here. I'm going to go to second, insert. I'm going to put in 2. So now y2 and y3 look exactly the same. I'm going to go inside my absolute value, and I'm going to go second, insert, and I'm going to put a negative right in front of that x. So you can see y2 and y3 look very similar. It's just that there's a negative in front of that x right there, where in y2 there isn't. So let's see how that changes my y2 from my y3. We're not comparing it to the parent anymore. We're just comparing it to the two functions. So that's the function that I have in my book. And now this is the function with a negative in front of that x inside the absolute value. So you can see that putting the function so that it's y equals to absolute value negative x plus 4 minus 3, it moved my absolute value function to the other side of the y-axis. So this negative, when it's inside in front of the x, actually does what's called a reflection over the y-axis. It's as if I took this v and I flipped it and it comes on this side. Well, what would happen if I had y equals -2 absolute value of x plus 4 minus 3? Okay, so let's try that one. So let's go down. I'm going to get rid of what I have here in y4. I'm going to do second insert negative. So I have -2x, and then I'm going to put in plus 4 inside the absolute value minus 3. So you can see these are all very similar, aren't they? The only difference is that in this problem, y3, my negative is in front of the x inside the absolute value. In y4, my negative x is outside the absolute value. So let's see what that what does. So this is my new one. It flipped my original problem from the book upside down. So if I have y is equal to -2 absolute value of x plus 4 minus 3, then this is called a reflection over the x-axis. Little tricky, okay? This one here you'll see a lot more of in Algebra 2. Every once in a while you might see it being reflected over the y-axis, but for the most part you just really need to make certain that you understand when it's reflected over the x-axis. It basically means the function's been turned upside down. Okay, so one last thing I want to say to you is that when we have our parent function, it looks like this. But things can happen to our parent function. So a number of things can happen to our parent function. And you can see I've put some letters around that x. So we saw up here when this 2, that's just like our a here, that would be like 2. My b in this case, I don't have anything in front of that x, so that would be like 1 times x. My h, remember this is minus, my h is actually -4 because that was the x value in my vertex. And my k is this -3 out here. I should probably really put plus -3. So if we were to clean this up, I get 2 absolute value of x plus 4 minus 3. So this form right here is a form you'll see again and again with different transformations of functions. For the most part, we simplify it because we don't worry too much about what's happening in front of that x. So oftentimes for this class, this is the form we're going to look at. We leave b to be equal to 1, and when b is 1, we just have x by itself.